good example of global collaboration, haven't you, in South Africa at the moment?
Thanks, Vivienne. I suppose we do, and probably more than one, but a couple stand out as the sort of key examples of the vital nature of collaboration, things that simply wouldn't be possible without collaboration, but could offer, significant new knowledge to the world and offer something in the form of global knowledge. One would be in perhaps an unlikely area for a small country, a country where the science system is relatively small and the research capacity, excellent scientists, excellent researchers indeed, but it's quite small, is in the area of astronomy, and in particular radio astronomy, where just a couple of years ago we were awarded, along with Australia, with the lion's share going to South Africa, the honor of hosting what will be, by a very long way, the world's largest radio telescope, and will be one of the truly mega science projects of the world. And it was awarded to South Africa and Australia on the basis both of site suitability and capability. But just to give you a sense, Vivienne, if you don't mind, on how big it is and how it is an international collaborative effort. I mean, astronomers around the world tend to work very closely with each other anyway, because we can't all have the facilities. The facilities are very expensive. This radio telescope, called the Square Kilometre Array, I'll talk about the African component now. It will be largely located, these very large dishes. I see there's a picture of it behind me. These very large dishes, these dishes are something like 15 meters in diameter, and they're all swiveling and they're all talking to each other. The Square Kilometre Array will consist of 3,000 of these dishes, mainly located in South Africa.
3,000?
3,000 of them.
It's awesome. It's awesome, isn't it?
With eight African partner countries, and that's very important. But just to give you a sense of the scale of it, I mean, well, what will it do? We sincerely believe it's with its sheer power, it will make it at least 50 times more sensitive than any radio telescope that currently exists. So it will give us answers to, or some insights into the early formation of the universe, the early formation of stars and galaxies. It will give us more knowledge about things like dark energy and dark matter that we don't really know much about. We know it's there, but we don't really understand it. But just the very data that will be generated, will have to be transmitted, would be 100 times, this is estimated, by the time of its completion, 100 times the current internet traffic. So huge challenges come along with it. The computing capacity that will be needed will be the equivalent of 1 billion average-sized laptops. So it is massive. A project of this nature, there is an international consortium which guides it. The first stage, which you see up there, is a South African project, and we see 7 dishes here. The next stage, which will be finished in about 2 years from now, will be 64 such dishes, which will make it the biggest radio telescope in the world in its own right. So just imagine what the 3,000 dishes will be. But there's a consortium of 11 partner countries, or member countries, many of whom are here today. I'm not going to list them because of time. But it can't happen without this kind of global collaboration. But I thought, Vivienne, if I were just to talk about this mega project, it would be a bit misleading, because I think it offers us knowledge, that's true, very important knowledge. But then there are global problems, as has already been said, that just know no boundaries. And I think of, obviously, climate change, and we're contributing towards that. But let's think of infectious diseases for now, and HIV/AIDS in particular. And this is the other driver of our initiatives and our research efforts into HIV/AIDS, is as a result, I suppose, of an unfortunate reality, and that is that 6 million people in South Africa are HIV positive. We don't like that reality, but the reality means that it drives us to be not just for the importance for us to find solutions and the imperative for us to find the solutions, but it offers opportunity to collaborate and to do clinical trials. One of our clinical trials conducted, which was really designed to test the applicability of tenofovir, an antiretroviral, as a microbicide in women to protect, especially women who are sexually active, to protect them especially those women who are unable to negotiate condom use. But as a byproduct of this clinical trial, and these clinical trials are very expensive exercises, we couldn't do it with our resources. So it's a really global project, if you like. Just recently, in fact a week ago, a paper was released in the Science publication, and one of the women participants had what we call what was found in the woman was a broadly neutralizing antibody, or broadly neutralizing antibodies. What's so significant about that? We all have antibodies if we're exposed to diseases, but the difference is that the HIV virus is particularly difficult for the body to cope with because it's mutations, a number of different strains, etc. But what was significant is that the scientists were able to isolate the antibody, clone it, and it offers real possibilities for advancing towards the discovery of, or possible introduction of an effective HIV vaccine. And this would not have been possible had it not been for very significant global collaboration. But the outcome is going to be of importance to all countries in the world. Thanks, Vivienne.
Fantastic.
Too much, I know.
No, we liked it. We thought it was fab. So, Minister Barañao, in South America, you have also a great history of collaboration.